How are you now? James Whelan here, occasional talking head for smallcaps.com.au. And on this beautiful sunny Sydney day, not really overcast, but a lot friendlier bits and pieces in markets and in people. And I am joined today by Nick O'Loughlin, CEO of Sparc Technologies, stock code SPN on the Australian Securities Exchange. Nick, how are you now?
Good, thanks, James. Thanks for having me on today.
Mate, another one of my trademark ham-fisted introductions. Hopefully you do better at explaining your company and the future and the progress and updates than I do at actually talking about things and doing the job that I'm actually paid to do. So I will do my best, and then you can probably pick up after me for what it is that you do and how you do it. Sparc Technology operates under two technological pillars. Their graphene additives development called Ecosparc, which recently secured proof of commercialization with their first contract, and their hydrogen project, which is a pilot plant out at Roseworthy, currently operationally testing hydrogen generation. How did I do with that one, Nick?
Yeah, pretty well, James. So that's right. We are a technology business with two segments, and we have different approaches to each side there. The first one you mentioned is our graphene-based additives, which we develop in-house here in our labs in Adelaide. And we have been developing a product called Ecosparc over the last 5 to 6 years, which has been testing in the protective coatings market. These are coatings that are used on steel infrastructure like the Sydney Harbour Bridge, mining infrastructure, jetties, ports, oil and gas, etc. It's a massive market. And what we've done with our additives show under lab testing and now field trials that the additives significantly improve the durability of those currently used protective coatings, or a big chunk of them. So we are approaching the market with that additive. We made our first sale in December last year, and we're rapidly approaching our first contract in a widely used protective coating.
Okay, now we will get to that, the first sale and details beyond that as well in just a moment. So the two major problems that you're working on, so you've got how to stop materials from rusting. You mentioned the Harbour Bridge, one of the classic ones. That's the graphene side. And how to make the cheap green energy on the hydrogen side as well. So someone is looking at Sparc for the first time. From an investment perspective, how would a client look at that?
Yeah, look, so I think and what I get told as well, feedback from the market, is that the graphene is kind of certainly the near-term commercialization story around the company. We are now in the market selling additive and hopefully ramping that up quite rapidly. And the hydrogen offers quite I would say significant blue sky. It's a joint venture we're involved in with Fortescue and Adelaide University. It's been running for 4 years, and we just appointed the CEO for that joint venture in December last year, a lady by the name of Alana Barlow. We hold 36% of the JV alongside Fortescue with the same interest, and the university 28%. And it's developing novel hydrogen production technology, which importantly for your listeners is decoupled from the cost of electricity. So the incumbent green hydrogen production technology is using electrolyzers, which use a lot of electricity, and therefore the cost of hydrogen is driven by the cost of that power. Our process uses a different method called photocatalysis, and we're now piloting that, as you mentioned, up at a site in Roseworthy, which is just north of Adelaide. Completely novel way of producing hydrogen, uses a photocatalyst material in direct contact with sunlight and water, and we're now proving that in the field. So a lot of excitement there, a lot of blue sky.
Now, we're going to get to that. We're going to get to that in just a moment as well. But if let's talk about the corrosion problem. Now, I've heard you say that the world has a multi-billion-dollar corrosion problem. Ecosparc is essentially a drop-in solution. So putting it simply, why would a paint company choose that additive over something that they've been using for the last 30 years?
Yeah, so Ecosparc's been developed for epoxy-based protective coatings. These are coatings which have been largely unchanged for the last 30 or 40 years. Yes, there are some performance boosters that are kind of available in the market, but nothing has had the impact that our graphene-based additives have shown time and time again in the lab under what's called cyclic corrosion testing. So we've done 9 rounds of that testing with our additives into commercially used protective coatings, seen an increase in performance boost of anywhere from 26% to 79% in terms of the corrosion spread to the international standards that are used there. Massive impact on the durability of the coating. That ultimately extends the lifetime between maintenance events for asset owners. These are asset owners like your BHPs, Centoses, government asset owners. We're working across all of those names on field trials, and increasing the life between maintenance events saves those owners significant dollars productivity benefits, and there's also safety benefits as well. So it's a really strong pitch to that end of the market.
So enough to make someone move, or definitely consider a move, which is fantastic. So let's talk about your first commercial sale with a customer in Asia, and you mentioned it at the top of the show. Let's dig into that now. So huge milestone, congratulations to you. Now that you've proven that people will buy it, how does your capital light model help you move from this first order to becoming a standard ingredient in industrial paints worldwide?
Yeah, so what we sell is an additive, which we produce by the kilo. We sell it in what looks like a paint can. That is then sent to the coatings manufacturer, and they tip it in at the point of manufacture, just like they do a pigment or other additives that are used day in, day out by those coatings producers. So our customers are the coatings manufacturers, and we're working with 5 of the 8 largest protective coatings manufacturers on testing and trials, which is really pleasing. The sale we made in December was that, I guess, connection point into commercialization for the additive, which is fantastic. And now the goal for the company is to have fully fledged products released with our additive included in them. And pleasingly, we're not too far away from that, I believe, which will then generate ongoing revenue, growing revenue. And we're talking about coatings products which are sold in the millions of litres per annum. So we can produce enough additive to dose about 4.5 million litres of coating per year. That may sound like a lot, but that's only about 5% of the Australian market in protective coatings. And we earn about $1 per litre of coating that has our additive in it. So the economics there are really strong, really high gross margins, really low capex for our manufacturing facility, and really quite easy to roll out.
Yep. Dollar a litre on that one. And like you said, good margins, which is good. Now, that's great. Let's go to the other side. So we've certainly, the Ecosparc, that's good. Let's go to the other side, the hydrogen side. You've reached a point where the hydrogen pilot plant in Roseworthy is working and producing. Fantastic. You've said the next step isn't about scaling, but it's about economics. A subtle difference there, quite a substantial one, I think, though. What does success look like at that pilot plant over the next few months to prove that it can be done cheaply?
Yeah, that's right, James. So we switched the pilot plant on in December of last year, and we're now running the pilot. And the first step is to benchmark the performance of under the real world conditions with what we see in the laboratory. So we're using very well-known catalyst materials, which we've been using in the lab for many years in both the pilot and then looking to benchmark that against what we see in the lab. They're materials from collaborators in Japan. The next step, and a really crucial step, is to then look at some higher performing photocatalyst materials. This basically means that you produce more hydrogen per unit of sun or the solar flux. And these materials are really, an order of magnitude more efficient than what we have in there to commission the plants. Next step is to move those materials from the lab into the pilot plant. We're looking to do that hopefully by the middle of the year. And that will provide a really strong economic case to take the technology forward in a scaled way, which would then be producing commercial volumes. So that's a really important step around what we're doing within the joint venture. And again, this is very novel technology. No one else has reactor technology for photocatalysis that looks like ours. And we're taking a leading position in that space with some leading partners as well, which could really drive significant value.
Yep. And that's where I wanted to go into it, Nick. And I've done some work with hydrogen in the past, but maybe for myself and the punters as well, talking about the exact difference of how the hydrogen is created through this method.
Yeah, exactly. So photocatalysis uses photocatalyst materials. These are highly engineered semiconductor-like materials, which can effectively split water in contact through sunlight directly. So you're not having to produce electricity through an electrolyzer to split water into hydrogen and oxygen. With a photocatalyst material, water and sunlight, you can do this exactly the same thing, effectively automatically. And it's called a direct solar to hydrogen technology. What we're looking to demonstrate with our pilot is doing that not only in the field under real world conditions, but doing it under increasing efficiency levels, which support the commercialization of this method going forward. And this would be, world leading in its approach.
Yep. Well, especially with electricity. Well, I've seen some amazing stats about how much electricity is going to be used by data centers and not being used for the energy behind it. So that's great, especially with rising energy costs. I think that's a sensational way of going. Now, if we talk about the future, we're going to talk about you and I sitting here in 12 months' time, Nick. What are the 2 or 3 major updates that you hope to have shared with the market by that time? What can investors expect over the next?
Yeah, so look, James, in the near term, it's all about ramping up the commercialization of our Ecosparc additive for the protective coatings industry. We're approaching contracts there which would support the use of the additive on an ongoing basis. And these are with global protective coatings companies and could see, hopefully fairly rapid uptake of volumes of our additive within that industry. So I'm hoping that we'll have the first one of those in the next few months and the next couple of products, certainly by the end of the year. So having 3 or more protective coatings products with our additive in it is a really strong platform to utilize our current manufacturing capacity. And then we grow from there in a modular way. On the hydrogen side, I think it's all about proving up the piloting of, as we're doing now, the benchmarking then into utilizing some of these high performing catalyst materials, securing partnerships on that basis, and then looking to put together effectively the business case to take the technology forward from piloting into that commercial scale. So I think we're really well positioned to do that, having ticked off a couple of those milestones over the next 6 months or so.
Excellent. Well, that's a perfect plan. Now, Nick, that's all that I've got time for us, but I am really looking forward to seeing what's ahead for Sparc Technologies. Thank you so much for joining us. Nick O'Loughlin, CEO of Sparc Technologies, stock code SPN on the ASX.
Many thanks, Jack.
Have yourself a great one. Everyone stay safe out there and all the best.